Good morning.
Morning.
Yeah, good morning. First, let us discuss on the exam paper. So if you have any doubts on that, you can ask in the sense that if you have any questions that are not very clear in the exam that I have given, we can discuss that. Okay, and then I will move on to the discussion on neural networks. I'm sharing the paper here just to bring the discussion. So first problem I will discuss at the end. Okay, second question. Here is a binary image that is given, or binary image patch, 5x5 patch that is given. You are asked to find out the gradients in x and y directions. Most of you have found gradients correctly in both x and y directions. Some of you tried to use slightly different operators than what is given. After finding gradients, what is asked is to find out a use a average weighted mask, okay, to compute the elements of covariance matrix M. So first you have to form the covariance matrix M with the elements. Say the elements are ix square, iy square, and then ix iy, as you know, in Harris corner detector. Since you have actually ix square, ix iy already with you, you can easily calculate ix square, iy square, ix iy. That is suggested only for the central 3x3 region. The reason being, if you consider up to here, there is no issue of border effects. Because if you place a 3x3 mask here, or if you find a gradient using these two or these two, okay, you don't get affected by the borders. So that is the reason usually people do in the interior, leaving the boundaries. Even here, it also helps us to check in a smaller patch or region how you compute ix square, iy square, and so on. And then you will get ix square, each of them 3x3, ix square, iy square, ix iy. Okay, and then averaging mask convolution, if you are supposed to do at the central pixel, means what? Convolution at the center with a 3x3 mask is element wise multiplication and then sum, that's all. So some of you have found this task as not very clear, in the sense that some of you have done in different ways. So what essentially you need to do is, first you need to form ix square, iy square, ix iy, then apply the average weighted mask. That is 1 by 9 times of 1, 1, 1, 1 everywhere. Okay, so with that you should do convolution at putting the mask also here, element by element multiplication, summing them and putting the value at the center. So finally at 3x3 you will get only a single value for w convolved with ix square, w convolved with ix iy, w convolved with iy square. Okay, so putting those values together, you have the matrix M. And then you can find out the R value by using determinant and the trace of that matrix. Okay, so most of you have done fine, except that some of you probably are more confused here. Some of you who have not understood the gradient finding itself has to look back carefully, because that's a very elementary operation in any of the feature extraction or in any of the image processing tasks. Even for the second task, what you need to start with is the gradients ix iy. After that, what you need to find out is the magnitude and the angle of gradients, tan inverse of iy by x and root of x square by ix square iy square. Then what is asked is magnitude weighted angle histogram for HOZ vector. So this, since if you see, the magnitude will be 0 at most of the places. Essentially for all 0 degrees angles, okay, the magnitude is 0. For 45 degrees, minus 45 degrees, 90 degrees, minus 90 degrees, there are some magnitudes, either 1 or root 2. Based on that, you can find out a magnitude weighted HOZ. Most of you have done fine, except that some of you have done binning slightly differently and so on. That's a minor, like probably missing of the appropriate binning. Otherwise, some of you like other mistake some of you have done here is not considering proper weighting for the angles. That is a reasonably important step that you need to understand if you have done that mistake. And then indicate a simple technique by which you can identify square objects of 2 cross 2. So here square objects of 2 cross 2 means what? 1, 1, 1, 1 only. Okay, given that this is background and this is foreground, this is what you need to do. And convolution with that will give you the response wherever the square object is found that as higher value. See, most of you have written that by using convolution with the template of 1, 1, 1, 1, okay, we'll give the locations of the square patch. It is not enough just to write the convolution will give, but you need to indicate after convolution, you have to perform thresholding. Okay, because convolution is nothing but correlation here because it is a symmetric mask. Okay, once it is symmetric mask, what we do is we perform correlation or convolution, and the score of correlation will be higher. Okay, so it's not that the correlation directly gives you the solution. Correlation will give you a value, okay, a response value at this location, at this location, at this location, and so on. Okay, but the correlation being high or above a threshold, if you consider normalized cross correlation, then it is above 0.8 or whatever. So it is in the range -1 to 1 or 0 to 1. If you consider all positive, 0 to 1. Okay, so in that case, the 1 means it is exact match. 0.8, 0.9 means a good match. Okay, so convolution is not the end for finding the template matching. After convolution or correlation, you have to perform thresholding. Okay, that is what is being missed by many. Of course, I have not subtracted many marks for that, but that's also an important point. Okay, I think the key steps of scale invariant feature transform, many of you have written, some of you have written in a different manner. So some of you have elaborated too much on a single step, but what is asked here is to outline all the 4 steps. Okay, when I ask you to outline, just writing, say, scale space peak selection, okay, and then outlier rejection, that is also okay, but that's not very good. So you should write at least one more word about it, one more sentence about it. Scale space with the peak selection means what? So you use the difference of quotients or the LOC, Laplacian of Gaussian, and there you try to figure out which is the maxima or minima. Okay, that gives us the feature points. So like that, if you write, your understanding will be clear. Okay, the questions that we ask are not just to make some evaluation or assessment for you. Okay, these are mainly to see the reflection of your understanding. Okay, so that has to very transparently appear there. Okay, in fact, I should be surprised to see the level of understanding you might have got. Okay, from your writings. Okay, that I see it in some papers, but I would suggest that you also learn to write to the point and very clearly what you are understanding on the asked aspects. Okay, give the mathematical description of exact key points that extracts key points in shift. Okay, even for this, some of the what is I expected is the Laplacian of Gaussian gives the key points, and Laplacian of Gaussian is computationally intensive. So we approximated by difference of coefficients and compute it a difference of coefficients at different scales, and then you find out the peak of that. That's what is I expected. But some of the students started writing the other steps, the Hessian matrix, and then R values there. It's okay. It's nothing wrong to write, but not asked. So to go to that extent. Indicate how orientation invariance is obtained. Here also, some people have described how HOC vector is extracted. But the question here is not how HOC is extracted or shift descriptor is extracted, but more on how we achieve orientation invariance there. So essentially, you find the dominant orientation of that key point, and then you also note that, okay, and represent the key point with reference to that or subtracting the dominant orientation. So whether the key point is in this way or that way, you will get the same orientation vector. Okay, or HOC vector describing the key point. Okay, and that value of dominant orientation also is stored. And while matching, they will also use that if necessary. Okay, so that's, I think some of you have written. Then here there is a good confusion. I think bag of visual words, you people have written reasonably fine. So it appears that at least some of you have captured, if not all, what is bag of visual words. But where the dimension of bag of visual words, many of you have written mistake there. See, the shift vector dimension is 128, and then the visual words are 500, code words are 50. What would be the dimension of bag of visual word feature vector? What do you think? Any answer for this? What do you think is the dimension of bag of visual words vector? No answers? Okay, I think none of you have written or what in exam? Okay, so the answer is 50 cross 1. The reason is, what is bag of visual word vector? We represent the feature points in any of the image. Okay, through shift, what we establish is the correspondence, or to find out to which code vector a visual word belongs to. That's what we see using the shift descriptor. Okay, we have 500 visual words and 50 code words. So each of them goes to which code vector is what being seen. How to see that is using the shift descriptor. You have shift descriptor for the code word. You also have the shift descriptor for the visual words, and the distance between these two will tell us, okay, to which code word this either of these 500 has to be matched. So finally, what happens if once we match, out of this 500, 100 may go to the first code word. Okay, 5 may go to the second code word, and then 2 may go to the third code word, and 20 may go to the fourth code word, like that. 50 code words will have their frequencies out of these 500. Okay, that frequency vector of these code words is referred to as bag of visual words feature vector. Okay, so the dimension of bag of visual word feature vector finally is only 50 cross 1. Okay, but however, for computations you need all this. Okay, so I have given this information just to mislead you. I think I was successful to mislead many of the students. Of course, the understanding was given in the previous lectures. So if you could refer properly, I think you will not get confused by these additional terms. If I ask the computations, number of computations required to establish the bag of visual feature vector, then it is, you have to have the full understanding even more, and you should be able to compute and tell. Okay, in case if it is asked. Then state the key steps of Viola-Jones phase detection. Many of you have written, some of you have written simply of Haar feature extraction and then integral image, okay, and then Adabus classification and cascaded approach. But what I would expect, as I mentioned before, is not just stating that. Even though I asked you to state doesn't mean that just state these brief or state the headings, state the steps. Okay, so you need to give at least one sentence description of what Haar feature vectors are. So you can say that they are like, they extract the difference between the white and black patches, okay, in the neighborhood, for example, some description of that sort. Okay, they are like binary feature extraction methods. Okay, with half being white and half being black, are different combinations of that. They will try to see where the locations of eyes are, noses, etc. Also, some such description has to be given. To implement that better, people use, or we can use integral image. So no need to describe the whole thing. Some of you either have gone to the extreme of describing the whole thing, or some of you have given just the those force and words for steps. If you have any questions on these topics so far, you can ask now on this question so far. Now, then I will discuss question 1.
So, in the second question, can you please go to the second question?
Yeah, fine. Sure. Yeah, yes, Ketra.
In the A part, in the B part, first question B part, weighted average. So
Yeah.
in this, do we need to consider weighted average? I mean, you have given it a
Okay, so you instead of direct average, you have considered as like 4, 2, 2, 1 kind of weighted average, is it?
so,
That's not a problem. See, even if you consider it, it's okay. Only thing is, you should not consider before calculating ix square, iy square, ix, iys. Okay, you should calculate the ix square, iy square, ix, iy matrices of 3 cross 3. And that you can consider. Okay, and the values will be slightly different. But anyway, I didn't give much weightage to the values or the calculation mistakes. Okay, some of you instead of writing when I said weighted average, and they have first convolved with ix square and then got the square. Okay, they for the whole thing. First convolved with ix and then squared. Okay, so then what happens? 1 by instead of 1 by 9, 1 by 81 will come there. So some such mistakes people have done without, of course, making mistakes in ix square. I don't consider too much on that. So similarly, weighted average also will change only numerical values. Procedure doesn't change.
okay.
Yeah. Any other doubts or questions by any? Okay. If there are no questions, let's move on to the discussion on the first problem. So did any of you notice what is this first problem about? Any of you have any idea on seeing this problem? What I am trying to make you do? Students are there in the class or not?
It was like kind of computing the model for a task of ML task. Like,
okay. Can you repeat again?
it was kind of computing the ML task, and then checking if the loss function and everything.
Right. Okay. Okay. What else? Any other comments on what is this closely resembles? Some of you have taken machine learning courses, I think, already. Have you not seen this as a one layer of neural network?
So basically calculating the loss function, like S is the predicted output and T is the actual output. So the distance between them, like the error.
Okay, fine. So this essentially, as Abhimanyu mentioned, and you also are mentioning probably, this is essentially finding the correlation with respect to the image samples, okay, with each row of the W, okay, wherever the correlation is high, okay, for that row, say if it has 10 classes, X can belongs to first class, second class, third class, and so on, okay, 10th class. Now, if the X belongs to first class, the correlation with the first row of W has to be high. Okay, that's how we are trying to train this model. Similarly, if X belongs to fifth class, the correlation with the fifth row of W will be high. High means what? Higher than others. Okay, that's what it's supposed to be. Okay, I have not explicitly put that condition of higher than others, but in fact, it has to be put to train the multi-class classification problem. Okay, we will discuss this in more details little later. If I use a kind of, instead of directly taking the mean square error, if I use a kind of if I use a softmax function, whichever I have defined here, okay, at the end of yes, then if I use the loss function, cross entropy loss function and backpropagate, this is nothing but exactly one layer of a neuron, okay, or one layer of a neural network, because you have actually multiple neurons here and here. Okay, one layer of neural network. So that I will discuss anyway today. Once I discuss, you will be clear. Okay, and I hope you should be able to relate this to a neural network or neuron, and neural network for multi-class classification problem as well. Okay, for time being, it is essentially learning W such that if X belongs to a particular class, that row will have the higher score than other rows. Okay, and that is higher score as given by the correlation, as given by the target scores. Okay, that's how it is. Okay, but anyway, here I have used this to verify your knowledge of finding differentials. Okay, and which are already discussed in classes. So what I will do is I will probably I will start now the discussion with the notepad. If you have any questions in the paper, you can ask. I will discuss the first question also and then continue with the discussion on your reports. Okay, let's understand about, let's start with the same problem that is given. Okay, and then move on to the discussion on neurons. See, in the current in that problem, what is given is you are given an input X. Okay, you are given it is multiplied with a matrix W, and then WX is what is output. This is in some sense net value, or Y, or S is written here. Okay, and then what we are doing is we are subtracting this. Okay, with the target scores, and then what we got is what we get is essentially S minus T. You can consider this as theta or error. Okay, and then we are finding out the norm of it, norm square of it. Okay, so this is the error is nothing but S minus T into S minus T transpose. S minus T transpose into S minus T. Okay, because S minus T is a S minus T is what it's a column vector. So here this is D cross 1 and then C cross D. Okay, I'm giving general dimensions. Okay, and then this is C cross 1 and then this is C cross 1 cross C, right? And then so what is asked is dou A by dou S, which is, so many of you have done correctly, some of you have done even mistake here. Some of you have expanded and did fine, whatever way it is S minus T, 2 into S minus T. Usually what we define is half of this is what we define as the cost function. Okay, so and then dou what is next asked? Dou S by dou SK by dou WJK. This so many of you have written lengthy essays on this, writing so many expansion steps and so on. Okay, but in the class we have discussed, you can revisit it. What is this? Delta K equal to Z. When K equal to Z, then only it is non-zero, otherwise it is 0. The value at K equal to Z is what? Xi. Okay, ith element of X. Right, this is what you are supposed to get. And then what is asked is dou A by dou S, okay, which is defined as summation over dou A by dou SK and dou SK by dou WJI, summation over K equal to 1 to C. Okay, this is essentially what will happen. K equal to 1 to C will happen here. Okay, and then dou A by dou SK is nothing but 2 times S K minus Tk. Okay, because kth element is what we are picking here. Okay, and then dou Sk by dou Wj is delta K equal to J into Xi, right? And if we perform the summation, what is the answer? K can take 1 to C, but it is only non-zero when K equal to Z, because you are asking actually what are we asking? Okay, sorry. What is this dou Z by dou S or dou Z by dou Wj? Ji. Okay, what we are asking is dou Z by dou Wji. So it is non-zero only when K equal to Z. So the answer is what? What do you think is the answer here? Dou Z by dou Wji hence is equal to what? 2 times Sj minus Tj, because it is K equal to J only is non-zero, remaining all are zeros. Okay, K can take all values, but K equal to J is only non-zero here into Xi. Okay, this is the answer, that's all. So some of you have written lot of things for this. Okay, and then finally, what I asked is how do I update JIT plus 1? Okay, using gradient descent. Wjit minus what? Eta times whatever eta is not given, eta times dou Z by dou Wji. That is dou Wj. You can substitute. Okay. Of course, you can also write in matrix form. Okay, but I think that is a little involved. So it is better to write in this way. If you write in matrix form, then it will be eta times S minus T, okay, into X transpose. Okay, that will be in matrix form. Some of you have written, probably they might have seen somewhere, but this is the answer. Okay, this is also a matrix if you write in matrix form. Okay. Okay, any questions on this? As I mentioned, this is, I will later establish the similarity of this with respect to the neural networks and so on. Okay, but this is essentially learning a matrix W. Okay, learning a matrix W such that X belongs to omega C class. Okay, have high score for W, C throw of W. Okay, it's learning W in this way. Belongs to C class, we'll say. Okay, fine. Any questions on this? Fine. So the next question is anyway on the same thing, but it is considered the loss function is slightly different. So those who know the definition of cross entropy loss would have found it quite comfortable to write. But what surprisingly has happened is many of you have not have stopped at writing the after cross entropy loss function or after cross entropy definition. Okay, you have the expansion is missing. So you can see that S is again obtained by W into X. Okay, and then here I have mentioned this as softmax operation. Okay, what we mean by softmax is, okay, we define QK as we are converting scores to probabilities. That's what is happening here. E power Sk by summation of E power SL, L equal to 1 to C. Okay, because of this, what will happen? The range of Q will be all QK will be 0 to 1. Okay, so we are converting into the probabilities. Here scores can go from minus infinity to infinity. Okay, so they can go anywhere. But whereas QK is this range, that is the advantage. So now given this, we are given the target probabilities, P being target probability. Okay, and then it's only 1 for Cth class here, 0 else. Then it is only a binary vector. So then cross entropy, how do we define? So many of you have defined cross entropy. That's good. QK or PK ln of QK. Okay, minus sign. Okay, this is cross entropy. So in KL divergence, you have the other term as well, but in cross entropy, you only have this. So since PK is only non-zero for C equal to 1, okay, given this, what we'll have is PC ln of QC is the answer. But what is QC? Hey, some of you have written like this and then it didn't substitute. So the cross entropy here, is PC is 1, ln of negative sign, right? E power sk or sc here by summation L equal to 1 to C. Okay, so this is different. Okay, so we have written that ith class, right? So let's put that I itself. Okay, so this is what you need to write. Okay, of course, you can stop even here. Some of you have written little more, but expanded it, but I think it's not necessary. Okay, any questions on this? Okay, that's fine. So now let us continue the discussion, or let us start the discussion on neural networks. So before I discuss on the neural networks, would like to know, what do you know about neural networks? I just want to hear from you what you know about neural networks. Then I will start discussing it. None of you know nothing about neural networks. You can tell anything, what you know. So it's not yet started in machine learning course? Am I audible?
Yes, sir, you're right.
Yeah, yes. So you can answer what you know about neural networks, or is it started in machine learning course? MTech students, what's happening? You people are there or not? Bhavya? Reshma?
Yes, sir.
Yeah. So is it discussed in machine learning course or not yet?
In neural network, we are trying to learn, adjust the weight and learn things.
What is that?
In neural network, we are trying to learn, sir.
Okay, trying to.
The parameter.
Okay, in neural networks, you will be trying to learn parameters. Okay, fine. So what else? Any other students? What else you know about neural networks? You can tell if couple of words. See, I assume that you know neural networks and go ahead. Or how do I know whether you have any background or you don't have any background?
Instead of a single transform leading to the value, we have multiple transforms in between that lead to the final value.
Okay, instead of single, if you consider W into X as a linear transformation, okay, for X to extract better features. In neural networks, there will be several such transformations to extract the better features. Okay, that's what you are trying to say. Correct?
Yes, sir.
Yeah, fine, good. That's also one way of understanding. Fine, good. So what else? See, so far at the beginning, what we have seen is a nearest neighbor classifier. So in the current course of deep learning, what we have discussed for classification is only nearest neighbor classifier so far. What is nearest neighbor classifier? Say if I have actually a digit classification problem. Okay, assume that I just want to put some realistic numbers from a data set. So assume that there is a data set called MNIST. Okay, in this data set, we have actually the problem is to recognize 0 to 9 digits. And we have actually 50,000 samples. Okay, for each of these classes. So essentially what we have is 5,000 samples. Okay, per class, assume that. Okay, for training. In this 5,000 samples per class for training. Okay, and for testing, you have 10,000 samples. Okay, it is 10,000 means 1,000 samples. Testing. Now, if I am supposed to develop a nearest neighbor classifier, this is the nearest neighbor classifier. Okay. What is the difficulty? What I need to do? Say first test sample I will take. Then I need to compare with how many samples? Compare with how many samples? Up to how many samples?
8,000.
Oh, 50,000 samples. Okay. Each sample means a image sample, right? So it's a digit, either 6, okay, or 5, whatever. So assume that each sample is 20 cross 20 dimension. In fact, it is 28 cross 28 dimension. Okay. So for simplicity, assume that 900 cross 1 dimension. Okay, just to have simple numbers for our calculation, 900 cross 1 vector. So each sample is 900 cross 1 vector. Oh, for single test sample, how many computations are required? For single test sample, okay, to compare with all of them and to classify or put one of the class label, how many computations are required? So assume that we have, that's what we are trying to see. We have compared with all of them and then found the, say, correlation or normalized cross correlation. Okay, and then found that, say, yes, 560 sample is closest. Okay, by normalized correlation, this is closest sample. Then what do we do? What is the, how do you do classification now? The first test sample, okay, is assigned a label as 560, right? If S560 belongs to class 1, ST1 is belongs to class 1 or class 2. Okay, assume that this is S560 belongs to class 2. So then it belongs to class 2. Okay, if that is, say, if class 2, then this is also class 2, right? That's how we do. So now to perform this task, how many computations are required? One test sample classification. How many? I need some answers. How many comparisons am I making with a single test sample?
Comparison.
Yeah, 50,000. And then each computation, how many, each comparison, how many computations are needed? If you answer now in the class, okay, it will be just trivial for you to answer in the exam. I will not ask any, in fact, many of the instructors also doesn't ask too much high questions than what they ask in the classes. So I do not ask anyway. So if you answer in class means you can easily answer in exam. Okay. So 50,000 samples, each comparison takes how many computations? 900 computations, because 900 cross one vector, you need to compare means you need to find out the either product, element wise product, and then divide by them and so on. Order of 900. So this is order of, if you see, this is close to order of 45 into 10 power 6. So it is order of, this is close to order of 10 power 7 or 10 power 8. So these many computations per test sample, single test sample. Now after doing all this, okay, now if I wish to classify second test sample, okay, this is all for the first test sample. Okay, to classify second test sample. Number of computations required, how many? How many are required for second test sample to classify by nearest neighbor classifier? How many are required? Do you think that half of this are required? Or double of this? Or 10 times lesser than this? See, what do you do if with this second test sample? You take the second test sample and then you compare with each of them, and then you put whichever class it is closest to that class label. So how many computations will be required for the second test sample to classify?
Same number of computations.
Okay, same are required. So it will be how much then? So order of, again, you require 45 into 10 power 6. Okay, again order of 10 power 7. Okay, so if I keep classifying each of the test samples, do you think any reduction in the number of computations happen? There doesn't happen. And then total, okay, if I want to test, say 1,000 samples, okay, or 10,000 samples, test samples, the number of computations are 45 into 10 power 9. Okay, adding 10 power 10, in fact, adding, and this is close to 10 order of 10 power 11. So see, this is there any learning happening in this nearest neighbor classifier? Huh?
No, sir.
No, the reason being the number of computations you require for a first test sample is same as second test sample, third test sample, and so on. And you don't have anyway, every time you have to compute large number of computations to do. And the same procedure is followed. That means given the training samples of 50,000, you are not leveraging anything from that. Okay, you are just using them as the templates and keep matching with them. Okay, nothing is learned from the training samples. Every time you are redoing the same thing for test sample. Okay, the number of computations for each test sample are also very high because nothing else is learned. So in contrast to this is not a learning based method. From training samples. See, if I have a learning based method, what it does is from the training set, okay, what we get is some kind of learning parameters. Learning may be captured in terms of some parameters of the model. Because this, if you learn something, okay, you can crisply represent it. Okay, and that after learning, then testing happens. Okay, this is first we go with the training set. From the training set, you perform learning. From the learning, what you get is the model. Okay, model or whatever. After learning, what you get is the land model. Okay, or algorithm. Algorithm with those details. So land model we call because we already learned, and the parameters of this algorithm has this information of learning, whatever you have learned. From the land model, you perform testing. Okay, so there is neither no learning or learning model in nearest neighbor classifier. See, at least in the previous discussion that we had here, what we are doing, we are trying to see that for each of the input samples, okay, you start giving the input samples, x equal to, say, assume here also you have the input samples, training samples, 10, say 50,000. Okay, training samples. You keep giving each of them, and then you find out the error for all 50,000 samples. And what will happen? Some of them belongs to class 1, some of them belongs to class 2, some of them belongs to class 3, and so on. When I initialize this W, okay, randomly, that means no learning, no starting point. For learning. Okay, and what I do, I update this W such that the error here is minimized, not just for single sample, not just for single X, okay, for all samples. So here what I'm trying to do, for given input, adjusting parameters of the model. Such that the scores match with the target scores here. Okay, or the classification is training samples is correct. See, since I have trained with large number of training samples and made sure that for all the 50,000 training samples, one after the other, I will do that, not just with single X. Okay, I will present first one training sample, next another training sample, next another training sample, like that. When I present each of these training samples, what I'm trying to see, what is the error it has? Oh, is it corresponding to the correct class label or not, the output label? And then what I do, if there is an error, I will use it as a clue to update the parameters of the model. Okay, parameters of the model here we mean W. Okay, so this is the model. Model means what? How the input and output are related. Okay, that is the model. Input and output may be related by some set of parameters. Here it is only one set of parameters. Okay, this is called one layer essentially, because the learning is happening in stages. Okay, you can have another layer, and so on. Okay, we'll see that. So essentially what we are doing, this is the model, how the inputs and outputs are related, and the parameters of the model. And we are learning the parameters of the model using the principle of gradient descent here. Okay, I hope you people remember where we discussed gradient descent as an optimization technique. Okay, if you have actually a function, and if you are supposed to reach the local minima, okay, of this function, okay, from a given point W0, okay, what we do is we start here, you see the slope of this function, that is the gradient, and move in the direction opposite to the slope of the gradient. Okay, so here the slope is negative, so you move in the opposite direction. So it is now W1 will be here. Okay, again see the slope. Okay, again see the slope. After seeing the slope, see move in the opposite direction, and then this will be, okay, W2. Okay, like that. You keep moving till you reach, okay, till you reach the W minimum. Okay, so this will happen in gradient descent. How to move is being defined by this expression. Okay, wherein you can see that this is the gradient descent expression that tells us how to move. Okay, once we move like this, we reach the minima. Okay, we reach at least close to the minimum. That's what we have discussed in the previous classes. Okay, and if I perform like this with the training samples, now if I give a test sample, okay, then what happens? All these W's are trained such that if I present a sample in that class, the score for that class will be higher. Okay, and hence what will happen? Okay, when a test sample is given, okay, it also gets higher score for corresponding class or correct class. Okay, that's the expectation, and that is what is being done in especially even in neural networks. Probably in the next class, what I will do is I will start introducing a neuron from the biological perspective, okay, and then neural networks, and then establish the relation between what we already know a little bit of math and image processing or computer vision tasks to subsequently on the neural networks or convolutional network based deep learning methods. So if you have any question, you can ask quick question. Okay, so since anyway, I will discuss the neural networks in the next class. I will give a broad picture of the machine learning algorithms. Neural networks also comes as one of the machine learning algorithm. Learning means wherever we are learning some kind of parameters or a model, okay, with parameters such that it can map the set of inputs to the outputs. See what we are doing now. So if I have a model here, black box kind of approach, okay, what we are learning this more, we are giving the input as input sample. And what we are expecting the output label. Say if I consider X as input sample, some kind of F, okay, as model having parameters W, okay. So what I am doing is W comma X are the inputs to this F, and then what I'm expecting this to be Y. Okay, it some sense identifies for each Xi, okay, what is the corresponding Yi. That is the function I am trying to learn. Okay, so this is the learning function. This function is defined by what? Defined by model or architecture here, neural networks if we consider, or even the algorithm or method. Okay, and then what is this? These are the parameters of the model. W are the parameters of the model. Okay, and these are supposed to be learned. Okay, and what is this? These are the labels. And what are these? These are the input samples. Samples means what? They can be a image itself. It can be features of the image, HOG of the image, or whatever, histogram of the image, whatever. Okay, all these are samples. So what essentially is being established by this? What we are doing is we are trying to find out a functional mapping, okay, between the input and input samples and the labels. This functional mapping happens through a function f, which is maybe nonlinear, okay, function of several parameters, and those parameters are being learned, okay, by the optimization procedure. Okay, so this is what essentially is being done, okay, mathematically. In any classifier, there are different class of classifiers. One class of classifiers are statistical classifiers. Okay, and then the other class of classifiers are discriminative function-based classifiers. Can you tell one example for statistical classifier? With this, we'll conclude. And one example for this. Any statistical classifier, you know? Bayesian classifier is a statistical classifier. Okay, and then your neural network is here. Okay, we'll see in the next class why this is. Okay, and then discuss further. Essentially, the classifiers which takes the probability or probabilistic approach for understanding the samples, okay, and then map to the labels are called statistical classifiers, which doesn't care for this probabilistic or distribution of the samples, input samples, directly try to draw a decision boundary. Rather, okay, those are called as the discriminative function based classifiers. Okay, if the samples are given, okay, the first class of classifiers try to capture the distribution P of X given omega 1, okay, and then P of X given omega 2 and so on, and then try to put a decision boundary. The other class of classifiers directly tries to bring in some decision boundary to separate the samples. Okay, so let this be linear or nonlinear decision boundaries. Those are discriminate function based classifiers. Okay, we'll see that in the next class in more details. Thank you then. So probably let's meet physically in the next class in the permanent campus in TC22. Okay, the classroom I will probably mail you or message you in Google Classroom. TC22 is the classroom in which we will take the classes for both deep learning for computer vision and statistical skills. Thank you then.
Can you please share the midterm question paper in the Google Classroom, sir? Further.
Yeah, Kirtana, you are not audible clearly.
Sir, can you please share the midterm question paper in the Google Classroom?
It's already shared. You can see that. Thank you.
Sir, one thing, sir, classes won't be in hybrid mode, sir. It's difficult for me to physically come there, sir.
Yeah, you can attend online. Remaining students will attend physically.
Oh, okay. Thank you, sir. Thank you.
Thank you.